challenging to build platforms that are stable and scalable. Can you tell us a little bit about the systems you're working on at Sloane Kettering, and maybe suggest indicators that investors should be thinking about in terms of like infrastructure and data governance investing in this area?
I'll talk a little bit about our journey in AI because it is quite fascinating. I joined MSK just about 6 years ago, and at the time we already used AI, but again, traditional AI, neural networks, machine learning, deep learning, etc. Gen AI and agentic AI, etc. just accelerated what was already being done. But AI is a game changer in our research. Just a little bit about MSK. MSK is divided into what we call 2.5 parts. We have the hospital itself, which has the treatment, administration, etc. with 25,000 people or so. We have Sloane Kettering Institute, which is our research institute. That's about 8,000 people. And then we have the university. We're doing together with Rockefeller and Well Cornell. That's another 2,000. So it's a pretty large organization. But research is the heart of the things that we do. And today we have about 180 labs that we run. And 70% of the work that is done there is either done via AI or infused by AI. So AI is very, very much in the game across the board. And it is a differentiator. I'm going to give just a few examples and get back to the questions that you actually asked. But just to illustrate, one of the usages that we have is when we're looking at drug discovery, early stage and stuff as such. So we know enough about the genome of a mouse to create what we call a digital twin, which is a simulated environment that represents the mouse, and then we can infect it with a certain disease. And then we try different permutations as to different types of treatment and directions we are going with the emphasis to try to do as much as we can with immunotherapy, basically biologic agents for a variety of reasons. The first one is treatment is personalized, so the chances of success are higher. The second one is, when possible, we try to use the person's own DNA. Not always possible, most of the time not. But when we can do that, which solves basically the issues that Murat was talking about, which is the rejection. Because the body by nature will try to reject chemo, because chemo is poison, and the body will apply poison. As you suggested, 35% rejection, 65% okay, but 35 do matter. So that's another thing. And the third one is because it doesn't have the side effects of chemo or radiation. And one case, as an example, was 2.5 years ago we published a study about people that have rectal cancer. And we created an immunotherapy for them that was created basically by AI. In other words, we provided the different permutations. AI came with several solutions, quite a few of them. Initially, we had to tell AIs to make some changes because in the initial cases, AI basically created a wonderful treatment that will solve the cancer, but will kill the carbon life forms that is carrying it. So we had to tell AI, we actually do care about the life of the carbon life form. Please don't kill our patients. I had to change the model, but eventually we came to models, and then a novel idea came from the AI on something that we did not foresee. We did tests initially, of course, it was all in simulation, it worked well, then we tried with real mice, moved to actually to people. The initial study was 12 people, because it's relatively rare, and then we did it with 200 people. So I'm going to open the question to the audience. Out of the total populations that we tested the drug on, what do you think, how many do you think percentage-wise got full remission, totally cured? Anybody wants to guess? Less than 1%, okay. Anybody more optimistic? Well, let me tell you this, and please Google it, because it's hard to believe. 100%. We didn't meet a single one. Now, we are very careful with this, because something will happen, it's not repeatable. But 100% of the people that were in the test had 100% remission. Never before, never after did we ever get to this. Now, by the way, if it turns out to be eventually 70 or 80, we'll be happy. But it is an unbelievable rate that we never saw before. That's part of this. Now, the second part of it is de facto that saves about 10 years of research because we use the simulations first, rather than have 150,000 permutations going against 150,000 mice. So that is a real game changer. Now, one of the things that is important to understand is that to get to that, to do all the genomic sequencing, to do all of the cell splicing and the understanding of the protein takes a huge amount of compute power to do that. So we have a pretty large GPU farm. It's about 1,000 GPUs. Now, by the way, in the past it used to be known as huge. Now with all the Elon Musks of the world, etc., we are a little shrimp for NVIDIA, but relatively speaking, it's still pretty large. That's what it takes to do that. And what we have shown is there is so far a linear relation between the ability to compute and the speed to resolve issues within cancer. So it basically means the more power you have, the faster you're going to resolve it. As a result of that, we actually went and created together with Johns Hopkins, Dana-Farber, Frank Hatch from Seattle. We created what we call 𝐇𝐢𝐭, which is the Cancer AI Association, and we are trying to basically federate the data across all of us, because I think that to Nicola's point, the power is in the numbers, especially for rare types of cancer. The common cancers, we have enough data. At MSK, we keep the information of every patient that we ever have. So that's the data sets that we work on to begin with. Just for fun facts, in April of 1880, a woman named Karen came to us. She was our first patient. We have her records. If you want to see it, I can show it to you. By the way, at the time, you either had cancer or didn't have cancer. Now we know we have a lot of types of cancer. So it's not very useful, but we have all the data. And so that's this part. So the compute power has a direct association to your question. The infrastructure is large and complex to be able to do that. The other part of it is basically making sure that the data is clean and the data is meaningful. Again, to Nicola's point, the data is not biased. Being in New York City, the majority of our sample tests at the time was basically, I would say, European descendant people, because that's what the majority of what we had. Now, knowing that this does injustice to the rest of the world, we intentionally went and expanded our sample test for people that are non-European and all around the world, so we can actually achieve the diversities that is needed to have the right set of activity. Another thing that is important is to make sure that the data ensure the data integrity. So besides the fact that AI tends to hallucinate, which is a fancy way to say lie, the other part of it is that there are influences from the outside, because at the end of the day, the core of AI is Bayesian statistic, which basically shows you that this is the most probable cause or probable solution, but it doesn't guarantee the solution, because it's just a probability game. So to make sure that it's clean, we need to use mechanisms like 𝐟𝐸𝐭 and some others to make sure the data is clean. The data is also contained within our environment, so you don't have noise from the outside. And we continue to do the human in the middle to really check and recheck against both false positives and false negatives. So when it comes down to investments and companies that we work with, by the way, as you know, there are probably 10,000 agentic AI companies in the world. Before we finish our conversation today, there will be 50 more. So it's very hard to identify the ones that actually have a solution that is sustainable and can grow. But that's part of the work that we do, is to identify, and we have a system, and again, if anybody wants to know, we can talk separately, how to identify the companies that we believe that actually will have an opportunity in the future, and the ones that will eventually go away as part of the bubble bursting. Just last comment on this one, which is, you probably all heard about in the MIT study, 95% of the AI use cases go to waste, there's nothing in them. What we decided to do is to ensure that we look at, for each and every thing that we approve, we require to have an ROI and an outcome before we do it. Now, ROI doesn't have to be financial. It is financial in many cases, but for example, shortening the time for drug is an ROI. Improving the life of our patients, as well as their longevity, is a measurable matter. So as long as they can address those, then we can get into the game.